Hey there, welcome back to the channel. My name is Chris, and today we're going to be working on a Haas controller and looking at how we get MNET up and running and use it to query information about the controller. I have this Haas controller here. It's actually a simulator, so it can behave like either a lathe or a mill, but really it's the same controller that you would have on a machine. This one is actually quite old. It has an RJ45 connector in the back to plug in an Ethernet cable, but that Ethernet really doesn't have a lot of capabilities. If you want to get information from it, you have to use serial. There's a DB25 serial on the back. We have to connect that up to a machine and use serial communications to talk to it. Serial communications with Haas is using what's called MNET, and so we'll take a look at how we make sure that we enable MNET, set up our serial port, and give it some commands in order to give that. We'll then take a look at how we can use some additional tools to make that a little bit easier for us. If you're watching this video, you're probably familiar with the Haas controllers, but I'm going to assume that you're not, so if you are, bear with me. The first thing we need to do is check the serial settings on our controller. So we come under the display, go to our settings tab. That's going to bring you into these settings. Which tab it comes up on is likely whatever the last one was. I'm just going to assume we're starting in general, but you might be in any one of these tabs up here. To navigate, we use the page up, page down, which are right here and here. As we click page down, it's going to go this way, page up is going to go this way. What might not be really obvious is some of these tabs have multiple pages in them. So general, if I push page down, it stays in general, but it gives us different settings. We're going to keep going down until we get to I/O. And under I/O, we've got our RS-232 ports, and here are settings for our RS-232. The ones that are going to be important initially is we want to set our baud rate, parity, stop bit, synchronization, and data bits. These doesn't really matter what you set them to, but they need to match what we're going to use over on the PC to communicate this. So you've got a couple options. You can either set something on the PC and then set these to match it, or you can just read these off. And then you can see here, I'm at 19.2, 8, and 1. So 19.2 is our baud rate, 8 data bits, no parity, 1 stop bit. The one that's really important, though, is 143, machine data collect, and here you can see it's on. To adjust this value, we just use the left and right arrow, and it'll toggle between those. We will need to make sure that 143 is on. If it's not on, the controller simply won't respond to any Q commands that we give it later on. For the serial connection, this box has a DB25 on the back. DB25 isn't terribly common for a lot of things, so typically what you'll need is a converter. This is a 25 to 9 converter, but because I didn't have the right gender on this, I had to put in a gender changer. So we've got this 9 to 25. This comes to a 9-pin cable, and it just passes straight through, heading toward the PC. And then here, the other end of the cable, I have a RS-232 to USB connector. Now this cable goes further, and that just connects into the PC. This could be plugged directly into a PC, but just because of the distance from this box to my computer, I had to put an extra cable on. One of the things to look for when you're buying one of these is look for something that says FTDI. If it says prolific, or if it doesn't say, it may not work with your Windows machine. So FTDI is the ones that I recommend that you use. Next, we just plug that USB into our PC. If you don't know how to determine where that showed up, you can just search on your computer for Device Manager, then run it. You can see here under ports, it says USB serial, so I have COM4. If you've got multiples here, the easiest way to tell which one it is I can unplug that cable to the Haas box, and it's going to disappear. Then I can plug it back in. So I know that this one is on COM4. Next, we open up any serial terminal program. This one is called CoolTerm, but there are several of them out there. We want to create a connection to it. So we just saw we have COM4. So I'm going to select that. These need to match the settings that we have over on the controller. And we had it set at 19.2, 8, and 1. You might want to go faster than 19.2, like 115.2. We'll just go with 19.2 for now. Now I'm going to connect to the box. First thing I'm going to do is hit enter a couple of times. You can see that the device sends back this greater than sign. So we know that it is at least responding. Remember when I said that you had to have 143 enabled? If you don't have that enabled, that's all you'll ever get from this is just this symbol. In fact, let me turn it off and show you the behavior with it off. So I've got it turned off on the controller now. Hit enter. I get this character. Let me send it a command like Q100. We'll talk about exactly what that means here in just a minute. You can see that it didn't really respond with anything other than this garbage characters, then gave me back that greater than sign again. If I turn machine data collect, so parameter 143 back on, now I can do Q100, and you can see that gives me back the serial number of the box. So in order to get information from that box, we can use a series of commands called Q codes or Q commands. Those all, as the name implies, start with a Q and will return some form of data. You can see that Q100 gets back the serial number of the controller that we're connected to. One of the most useful Q commands is Q600, which is to just read a parameter. So if you know the parameter number on the controller, you can query it. Let's say we want to read the x-axis position. That's at parameter 5021. So we can do a Q600 space 5021. And that tells us that the position is at negative 078. And if we look over at the controller, you can see that matches what's on the HMI. Now that you have a serial connection into your controller, you can write code to send commands, parse the results, do things like that. Now, if you're not a programmer, maybe you want to do something that's a little bit higher level, there are options there as well. First one I want to look at is using a product called Solution Engine. It's from Lex Energy, but Solution Engine right now is installed on a Raspberry Pi. It's actually on that blue box right there. That is connected to my network. It is also that serial line that comes out of this controller is just plugged into it, and that's it. So what that's doing is that takes that serial data and turns it into a standardized MTConnect data stream. So this is the address of that MTConnect data stream, and this is our current data, so I can refresh it. This tells us what our current data is. That engine has a whole lot of information in it, but if we take a look and find the Haas data, we can come down and you can see it is not currently running. There are a bunch of pieces of data here. And let's take a look. Let's come down and take a look at the axes positions. We've got coolant level and communication time and things like that. But is it connected? True. So that means that the Raspberry Pi is able to see that device. We've got our feed rates, speed overrides, things like that. But here are our axis positions. So we've got our X, Y, and Z axis positions. And we actually have the actuals as well. So these are commanded and these are actuals. So now if you have an MTConnect client, you can connect to this endpoint and consume that. Let's take a look at what that might look like. As a companion to the Solution Engine, we have Solution Builder here. And this basically gives us everything in this tree node. And I can drag this out. And now I can take a look at the Haas. Again, we have connected, which is on, the status, which is idle, what mode it's in manual, execution, it's currently inactive, and then these are our positions. Now, if I come over to the controller, and I just change the mode over to MEM, you can see the controller mode here changed. And then I'm going to execute this program. This program has an error in it. It's going to get about 3 lines in and then hit an invalid G code for this controller. I run it. It hits an error. Yeah, you can't really see it because it's washed out. But you can see over here on Engine that it says alarm is now on. So we've got data like our alarms, we've got our positions, a lot of that kind of information. So if I open up this controller and I go to the axis, I can actually plot some of these pieces of information, like our X position. If we're interested in that, we can go to a graph. There are a lot of pieces that can be done here. I'll leave a link down in the description so you can go take a look at this if you're interested. But this allows you to get some of that data in a standardized way and then not have to write your own code in order to parse those Q codes and their results. So that's really all I've got for you today. I wanted to show you how to set this all up and be able to get data out of it. In the next video, I want to actually look at using Node-RED to communicate with this. So we'll have a drag and drop kind of flow-based thing that allows us to interact with this controller and get data and do some sort of logic on another machine on your Node-RED machine. So keep an eye out for that video if that's something you're interested in. Otherwise, thanks for watching.